Okay, somebody keeping track of time? Somebody gonna yell at me if I run too? Okay, good. Because you know, the good thing about it is I can stand up here, no mask, so I might be here for a long time. So, okay, hey, thanks again for organizing this. Thanks everybody for coming. Okay, I mean, I know this is not a simple thing, and I can imagine that the organizers are, sweating blood to think about, the money and the investment and the time. So I think it's great that you guys pulled it off, guys and gals pulled it off, and that so many people, even under these difficult times, have come. So I think that's really cool. So thanks. So let me get into this, and I got to watch the time a little bit because I like to talk. So let me just talk a little bit about Postgres and the cloud and how to figure out where to go and why. It's a question that we get a whole lot, and I assume that everybody in this room discusses that quite a bit. So what I'm going to do is, I'm an academic. Long time ago, that's how I started my career. So, I always try to look at assumptions and try to figure out, based on assumptions and definitions, what one should be doing. So I'm going to take a quick step back to say, why are enterprises going to the cloud? Why are they getting off legacy? And then look at, okay, what is this cloud thing, actually? Because when you really think about it, it's quite a nebulous or foggy concept. I worked with a number of customers who tell me, oh yeah, we're going to the cloud. I said, so where are you going? Oh, it's in our data center. It's on virtual machines. Okay, well, is that really a cloud? Well, and then a big debate starts, and it's fruitless. So I thought, let's go to some authority who can kind of define what's a cloud, what are the properties that it should have, and I really like the National Institute of Standards definition for cloud. I find it useful, okay, as a way to say, here are the properties and the capabilities that one should have, and then use that as a decision framework. Okay, so first, why are enterprises moving to the cloud? There's 5 things on here. And one quote, and this is a true quote from a conversation with an SVP of database infrastructure at a very large financial institution. That's as far as I can go. And he told me, Mark, today it takes us 52 days to provision a database server for production. And that has to come down to hours and minutes. And for me, that's probably the best quote describing how desperate people are for agility. Now, unfortunately, that same company is trying to create an in-house cloud on virtual machines, okay? So they may be at it for a while. So agility is one thing, consumption-based licensing. And it's interesting how consumption-based licensing and agility play together. When I was an IT manager, I bought once a piece of software, multiple millions of dollars, for a master data project. Well, 6 months into the project, we figured out we didn't need this stuff. We actually would have needed something else to be more innovative and move faster. Well, there was no way back. We had spent the money. We were going to use this software or get fired. So we used that software. It was not good for innovation, not good for agility, and at the end of the day, it was not good for our company, okay? But there was no choice. So agility is not just go where I want to go, but also be able to make mistakes, recognize mistakes, and change course, okay? And that is something that with conventional license models, where you buy the software and then you own it, is actually very difficult for those reasons. Innovation. We've all talked about it, right? We all want a wide array of services available. And again, in the cloud, that stuff's available. If you want to try something, and you want to try something with, a new data warehousing software, you just try it. You don't need to buy it first. You don't need to go through 6 months of arguing why you need millions of dollars spent. You just try it. And if it works, you make the case and you buy more of it, okay? So it's those things that are coming together with global markets, which is really a problem because you need to serve the global markets out of a local data center. You can't build those things fast enough. They're too expensive, right? So, and at the same time, companies are going through data center closure. If I would count the number of big customers today that we work with who say, I'm getting out of my data centers, it's just, this is like the trend. Shut down data centers, okay? But at the same time, go global. The only place to go is the cloud. And then last thing, Never thought about it that way. But two CIOs during CIO panels told me, you know, I need to focus my people on where the value is. And today, too many are working on racking and stacking and connecting networks and installing operating system and all those things that are like, they're necessary, right? They're like the plumbing in a house. It has to be there, and if the plumbing doesn't work, the place stinks. But it's not really what makes the house what it is, right? It's not the first thing you think about. And the same thing, I think, is happening when enterprises are moving to the cloud. They would just want to get rid of these things that take so long and where they see no value add. So why are they getting off legacy databases? The number one reason, and I gave a webinar yesterday about migration, and the number one reason is cost. That's what they say. But when you drill in, it's actually, yeah, it's the license cost is one thing. But what's really bad about it is the inability to move, meaning it costs so much to go where I want to go. I have all my licenses. Why can't I go onto Amazon? Well, because those licenses are not okay for Amazon. So, you know, it's actually agility that gets constrained by the license policy, which gets reflected as cost. Lack of deployment options, right? I mean, we with Postgres, we're kind of spoiled because it runs everywhere. If you're on Oracle and you want to go on Amazon, well, it's kind of restricted. Yeah, you can do some stuff on Google, and really the only place where you can go and have some flexibility is in the Oracle Cloud. But if that's not where you want to go, what do you do? Okay? So, and all of those things kind of can show up as cost drivers. And then innovation. Right? Bruce told me once, you know, people come to the Postgres conferences because of cost. They stay because of innovation. If it was just cost, they would come once and get on Postgres and be done with it. No, once they're on Postgres, they come back. Okay? And so it's the innovation that really drives it. And then the future-proof stuff, right? I mean, anybody doesn't believe that Postgres is probably the most future-proof thing, just listen to Bruce's talk about why Postgres will live forever. I think it makes a really good, to me, very convincing argument. So we, obviously, at EDB, and I think everybody in here, is convinced that Postgres is winning the database game. Now, if you look at the stock markets, if you look at the media, you don't get that impression. Because there's other companies out there who, for interesting reasons, make a lot more noise and get a lot more attention. But when you look at the data, it's actually Postgres. Right? And here's some data. I mean, DB Engine's ranking, maybe you want to discount that because it's counting Google queries, et cetera. So you could say, well, Postgres has so many queries because it's so buggy. Okay? I don't think so, but maybe that you discount that. But things like the Stack Overflow Developer Survey. This is the second time in a row that when you add up all the data, Postgres comes out as number one, by far. And 4 places ahead of who is right now the media darling. So let the data speak for itself, right? When we think about what is the logical place to go if you want to get off legacy databases. But the interesting part about it is, then let's say, okay, where do we go if we go to the cloud? Look at Datadog's survey about containers. Postgres, again, is the number one real database. I don't count Redis as a database personally. Okay? So, and the same thing in the Cloud Native Computing Foundation. Their tech radar shows Postgres as the number one real database. I mean, they have Elastic and Redis, again, listed first, but again, they're not really databases. Okay? So what's interesting is when companies think about where should I go for innovation, for longevity, right? And when I go to the cloud, Postgres, all data shows that, you know, Postgres is the logical place to go. So, you know, we're convinced, and I assume pretty much everybody in this room shares that conviction, that Postgres is the most transformative open source tech since Linux. It's in exactly the same place. It's doing the same motion that Linux did, okay? It's the same fight. It's the same fight saying, oh, it can't do it, we're all going to get fired, the phones are going to ring, right? Well, who still runs on VMS or Ultrix or, you know, all those things? They're gone. I mean, not completely gone, but they have been displaced. And the same thing is happening. If you look at the sales and the market share of the major vendor of commercial database software, their database software market share, it's shrinking, okay? Good. So I'm talking too much. Cloud service provider models. Let's dig into NIST. I'm not going to spend a lot of time on this one. It's pretty clear that when you look at the three models that NIST identifies, DbaaS is like platform as a service. It's not really software as a service, right? It's more like a development environment that somebody makes available to you to put your code on and store stuff. This is the much more interesting part when we talk about cloud. What are the characteristics? And these 5 characteristics are really important when you make a choice or when you recommend a customer to make a choice. 2 years ago, I was convinced that we could build the cloud by just using Ansible and Ansible Tower. When I'm looking at this, I'm saying, no, it actually doesn't work because it doesn't give me everything to be on demand. Yes, it allows me to provision on demand, but it doesn't allow me to react to all the events. It doesn't give me rapid elasticity. When I was talking about my customer before who says, I want to create an in-house cloud on virtual machines, well, they're going to fail because of rapid elasticity and resource pooling. Their resource pool is too small to be rapidly elastic. Okay? If they want more capacity, they still need to call Dell, rack and stack and wait and order and ship and all that kind of stuff. It ain't rapid. Okay? So these are really 5 things that must be there. Otherwise, it's not a real cloud. And that's why the NIST definition is good. 3 options to go to the cloud. We all know them. Here's my chart on how I would help somebody make the decision. If I go on infrastructure as a service, I have great flexibility, but I also have great responsibility, and I need to have great skills. So be aware of that, right? So if you can do it, it's actually the cheapest way of doing it, and you can do really interesting stuff, but you have to do it, okay? So as we go down, you can see in this chart here that some things are notably different. When you go to Kubernetes, what's interesting is you need to have less infrastructure knowledge because the operator does a whole lot of stuff for you, but you do need infrastructure knowledge. We have customers who say, oh, it's Kubernetes, it's easy. It's not. You really have to understand that stuff, okay? Once you understand it, the smart operator will do a whole lot of good work for you. It's really worth it, okay? But you have to understand Kubernetes. If we go down to the key elements, on-demand, rapid elasticity, and measured service, that's really where the difference shows up, okay? Because VMs on infrastructure as a service, even with Ansible, Ansible Tower, Salt Stack, whatever you use, that is not on-demand, rapidly elastic, or a measured service. Yeah, you can do the provisioning, you can do some things. It's certainly better than doing it manually, but it's not a cloud. Okay? No matter what you call it, at least not if you adopt the NIST definition. Kubernetes gets you a little closer, but it's not green on my chart here because the operator doesn't take care of the infrastructure stuff for you. Okay? It takes care of the software, and it does that beautifully if you have a level 5 operator, but it doesn't do the whole thing. DbaaS obviously does it, but you do give up some control, which is important because giving up some control is part of having a managed service and allowing that to succeed. So, as I said, VMs, even with a beautiful Ansible implementation, are not cloud, at least not if you adopt that definition. Kubernetes is getting you a lot closer. So if you want to get into an environment where you have a maximum of control, but also a maximum of flexibility with the right skill set, Kubernetes is a very, very interesting way to go if you have a mature operator. That's really, really the point that you need to figure out, okay? And then DbaaS, in my view, well, that's the closest to getting to cloud, okay? At some point in time, we'll have DbaaS that is more like SaaS, so I don't need to worry about a server anymore. I can just kind of upload my schema and I'm in business. Some point we'll get there, but that is the closest and the trade-off. So what's missing? I want to be specific. What's missing from Kubernetes? There's 2 things. What we call the control plane and the shared responsibility model. And the control plane is really what ties software and underlying infrastructure together for provisioning and for event management. Okay? That's really what's important. That's what's missing in Kubernetes. Okay? And then the other part is the definition of the shared responsibility model between the cloud service provider and the customer. And that is something that is very, very important. And that's also what differentiates right now the cloud service providers. The fine line of what they, for example, allow you to do in Postgres and what you cannot do. That's the shared responsibility model. What they will do for you, what you have to do yourself. It's obvious that you have to tune the queries, right? It's obvious that you have to define the schema. But what tools do they give you to tune the queries? That's where, that's where that fine line is. So really understanding that is important. But those two things is what Kubernetes is missing to really be a cloud according to the NIST definition. So what did we do at EDB? We took Kubernetes, our Kubernetes, Cloud Native Postgres Kubernetes, and in this picture you can see we have an operator that works around a Postgres cluster and then exposes different Kubernetes services for read-write, read-only, read service, etc. But for the rest, it's pretty standard, okay? With a smart operator that manages the life cycle, okay? So that's the first building block. Now, that's not everything. So what we did is then we introduced a control plane. And the control plane then ties together the Postgres operator and the Azure Resource Manager. Okay? So now the control plane can react to commands that influence both and, what's important, to events that are coming from both, right? Not just a software failure, but also a hardware failure. You need to expand the disk, etc. You need to tie those things together. So that's really where the control plane shows up. And then you have the shared responsibility model where you have the service reliability engineers working with you and for you, and it's very clear who does what. Okay? And defining that is really, really important. So that's kind of the nature of what's underlying a cloud definition. And for me, as I said, I'm an academic. For me, having a solid definition that I could use to say, okay, this is how I draw the line, this is what you need to have, and yes, you may call this cloud, but according to this definition, it's not, and you're missing the following things. I found that very useful in my discussions with customers when they're thinking about, okay, I'm going to go to the cloud, I'm going to get off my legacy database, where do I go, right? Part of the answer is obvious, the other part of the answer is not that obvious, okay? So really, in conclusion, 3 options. I like all 3 options, okay? And not one of them is wrong. It's just, you just need to know what you want, okay? VMs, even with good infrastructure as code, they're not really cloud, but they're really good, okay? I like them, okay? I'm not saying they're bad, but according to this cloud definition, they don't meet those requirements. Kubernetes is getting closer if you have a good operator, and that's a big if, okay? You need to have a level 4, level 5 operator. You need a control plane and a shared responsibility model to create a real DbaaS, even if it's an in-house DbaaS, or especially when it's an in-house DbaaS. We think Kubernetes is the right way to go to build one, okay? And if you build one in-house or build one for a customer or build one that is part of a bigger software as a service, I don't know, a billing system or something, we think Kubernetes today is the right way to go because you can encode so much Postgres expertise, operational expertise, into the operator. It's a great platform to do that. Okay? And then, in conclusion, understand the pros and cons. Make the right decisions. And I think that using the NIST definition as a framework to drive the decisions and not just talk with, waving your arms is really useful. It's helped me a lot. So hopefully this was informative. Thanks.